Let's look at the Conceptua Math program, and as we do so, let's begin by understanding its purpose. The purpose for Conceptua Math is to facilitate very high quality, personalized, and social learning. Look at the photos of the students. They're working with their own devices at a personal learning pace. They're working as a group on a rich task, having discussion. They're working as a pair in a think, pair, share, again, making their thinking visible, critiquing the reasoning of others. This is what Conceptua Math is about. And in order to accomplish this, it has to provide supports for teachers. One teacher leading in a whole class discussion, another in a one-on-one conversation about a student's personalized work, and the third example where the teacher is working with a group, again on a rich task. So Conceptua is about this kind of teacher empowerment and the kind of personalized and socialized learning for the students. Conceptua skill building lessons come in 3 chunks, where the student starts with an opener that lasts for 10 to 15 minutes. It can be a whole class or small group conversation. We see a snippet of these 2 girls' dialogue in the caption below. The student then moves into a guided lesson working at their own device. If they don't have their own device, we have a whole class mode that facilitates this 12 to 20 minute portion of the instructional setting. Then we move on to a closer, again where we're checking for understanding and we're drawing connections. The closer includes an exit ticket, a daily journal prompt. Look at this student's work. He's supposed to solve for the product of 5 times 742 and explain how place value leads to a good strategy. Notice how the student has separated their partial products and has a written description of why this is a good way to do a big multiplication problem. Real-world investigations are rich tasks that take place once a week. And in these, students are involved in using authentic data to tackle very interesting situations. There's also a fact fluency program built into Conceptua Math. It's almost a separate part in some regard, where students can log in any time for 10 minutes a day and have a completely personalized experience. So those are the main pieces of Conceptua Math. The Conceptua Math Grade 3 through 5 solution is built on a set of tools. You can find these tools on the website at conceptuamath.com under Free Resources, Math Tools. And you're going to find a plethora of tools in the areas of fractions, multiplication and division, and place value. We're going to look at 3 of these tools right now. The reason that these are very important is that Conceptua Math, in order to achieve its goals, uses these tools to create visual and conceptual understanding and move students from concrete to representational to abstract knowledge. Here's a tool on adding fractions with common denominators. If I start to type an addition of fractions problem, we see the model rendered. We can look at the model in different ways. When authors create content with Conceptua Math, they have the opportunity of representing using the set model, a number line model, an area model, and we're going to stay right here with these vertical fraction bars. Now, students want to impress their teachers, and they want to show how their knowledge is solidified. And yes, it would make absolute sense to say that 2/8 plus 3/8 equals 5/16. The student isn't necessarily being mentally lazy in this regard, depending on what they've understood. They're adding the numbers. Now, someone may say you don't add the denominators when you are adding fractions, but why would they know that? But when they have this visual representation, they can see it simply isn't logical. That in fact, if they can find a common denominator, they can see how adding 2/8 plus 3/8 is kind of like adding 2 apples plus 3 apples. Eighths are things, and now there are 5 of them in the sum. Moving to another model on place value. When we make a number like 1,200 234, we can see it in this representational model, which bridges between the physical base 10 blocks and the more virtual world or abstract world. Note also how we support the understanding of the standard notation, the expanded notation, and the English language verbiage. We move to more abstract models, and now we see what it's like when we have more than 1,000. It might be hard to represent that on a computer screen, but we can certainly see it with the base 10 block model. But with this model, we can move to higher numbers, and we're also increasing the cognitive abstraction for the student. When we move to this model with the disks, sometimes called Singapore disks, we can now represent numbers into the 100,000s. And again, we have this opportunity to show the various notations. Now, if we wish to do so, we can actually just look at the model only. And in general, this is true with the conceptual models, where we can move from models to procedures. Going back to the fractions model, the same thing. We can start this problem working with the model only. We can show this to students and say, tell us what this represents. Or on the other hand, we could start with numbers only and say, can you make a model that represents this problem? Get rid of the solution, and then we see what the opportunities are for that student. Moving to a third tool, we're going to look at the open array or area model for multiplication. Choosing two numbers, I'll multiply 22 times 43. We can see how this model organizes student thinking. We can find our tens times tens, and then our tens times ones. And notice how the algorithm is generated for us on the left side as we do this work. The way our modeling system works in Conceptua Math is that it can be linked to a procedure. It's possible that the procedure isn't shown at all, and you can also unlink it. So you can start a student on a new problem where, as they fill out the array model, the algorithm is not given to them, and they have to generate that work on their own. Moving back to fractions to see the same linking and unlinking capability. Using this unlinked mode, I can ask my students, make a model for this problem and explain how it helps you to find the solution. So we looked at three of the tools that are the underlying technologies for Conceptua Math. There are many, many other free tools. You can use them with your students. You can use them for whole class conversations. You can use them for student investigations. Students log into an assigned lesson and they continue with the theme that was presented in the opener. Most students will be on the same lesson as the teacher presented in the opener, but this is personalized learning, and some students will be ahead and some students will be a bit behind. As they move into their lesson, they're going to see stimulus that's very similar to what they saw in the opener, and in this case there's a video that very closely mirrors the discussion they just had, facilitated by their teacher.
In this lesson, we will be figuring out how many animals can eat given a total amount of food.
Students can be on an iPad, they can be on another computing device, a Chromebook, and as they move forward, they're going to be engaged in activities that are familiar to them because they were presented with these activities in the group discourse. Here they're to make a divisor of 5.5 to represent 5.5 pounds of hay, and they're looking to see how many groups of 5.5 or 5 5/10 are in 27 5/10. And they find those 5 groups and they move on. As they move through the lesson, the intention of the lesson is to move them from what is generally more concrete to what is generally more abstract. So they're moving from representations to procedures. As they do so, there's more video to support their journey.
In this set of problems, we will need to create the model for the divisor and the dividend. In this example,
so as explained in the video, now the student is responsible for creating both models. So here they create the model for the dividend, which happens to be 9/10. And then they make the model for the divisor. And if their answer is inaccurate, they're going to receive instructive feedback. They can read the feedback aloud using text-to-speech. This feedback actually encourages them to try skip counting by 3/10, 3/10, 6/10, 9/10. In fact, the program will never actually give the answer to the student. We have some 2 million data points, 2 million pieces of evidence that tell us that this works. Students can move ahead without ever being given an answer. They'll find it for themselves. So we explained before that students are moving from what is more concrete to what is more abstract. And notice at the bottom of the screen that now the student is seeing the division sign. So they're moving in that procedural direction. And in fact, in this next set of problems, in the next set, you will decide if you want to use the model. Now students don't have to use a model at all. If they know the answer, they can simply enter it and move on. And if they don't get the answer in an accurate way, they'll be given some feedback and they'll need to make adjustments. The guided lesson tends to take between 12 and 20 minutes, and each guided lesson culminates with a skills check. The data collection here is very important. In this case, there are 6 problems in the skills check. I'm going to get the first 2 wrong. I'm going to enter a quotient of 1 in both cases. And then I'm going to get the rest right. And as I do so, I'll be demonstrating a point. And that is that the teacher is going to have the opportunity to intervene, to be involved in the student's experience of remediation. So we're going to combine the principles of personalized computing, where the computer has recommendations, and what we call adaptive teaching, where the teacher is involved. So this student has failed the skills check. It says you correctly answered 4 out of 6. Review your answers with your teacher. At this point, the student's going to raise their hand, and lots of data tells us it'll be about 25% of the students. So in a class of 24 students, 6 at one point or another in the class period are going to raise their hand. Teacher comes over and looks at the answers. And she can see, in this case, that the student has answered 1. And the student could show, oh, I know the real answer. I can get it correct. Or it may be that in the brief interview with the student, the teacher discovers that the student doesn't really understand. So now the teacher has a quick decision to make. If the student did understand but was distracted and could do a better job, do the blue one. It's going to be very similar to the lesson they just did. If they need some more support, a longer lesson with more video and more modeling, try the orange one. It's a longer lesson, but it has more support. If they need to work on a pre-skill, well, let's see what the pre-skill is. Use models to relate multiplication and division in order to build understanding of dividing a whole number by a decimal. Interesting. So instead of decimal by decimal, whole number by decimal, it's a pre-skill. If they are assigned to the pre-skill, they'll do this purple lesson and then they'll circle back to the blue lesson. So you can see where the asynchronicity and the differentiation takes place. It's kind of like an RTI model built right in. If the teacher feels the student really understood, they just made kind of silly errors and I'm going to let them move ahead, well, then we can go ahead and click on the green, but the teacher's going to have to put in her own sign-in name and password for the student to move on. This is how the guided lesson works, and this is how the differentiation is accomplished. The Conceptua Math skill building lesson sequence includes a lesson opener, a guided lesson, and a closer. After about 20 minutes of having the students either logged in individually or working as a whole class, if there aren't that many devices, the teacher moves into the closer to summarize the learning, to make connections. Let's see what the closer looks like. Similar to the opener, the closer is designed to facilitate productive discourse, and then it has an added piece as well. And the added piece is a journal prompt. So here we see the initial discourse and this discussion guide. Let's apply what we learned to solve this problem on the screen. Take a moment to work through this problem with a partner. Let's have a few volunteers share their quotients. Do you agree or disagree with these answers? Let's have a few volunteers explain why they agree or disagree with this quotient. What is something you learned in today's lesson? So you can see how the quality of discourse is designed to have a brief discussion. Closures have to be brief, but they need to be pointed. They need to be well focused as well. So you're checking to see what the class understanding is, but now you get to move a step further and you get to check for individual understanding. Here's the journal prompt. Use a model to find the quotient of 2 8/10 divided by 4/10. Explain how you can use multiplication to check your answer. You can see how thoughtful this exit ticket is. Now it's up on the screen for students to look at. It's also in a printout. You see, each one of these lessons includes a lesson plan, and the lesson plan is available as a PDF online, and the last page of the PDF is the journal prompt. In fact, there are 2 journal prompts. The second one right here, use a model to find the quotient of 2 8/10 divided by 4/10. It's the exact same thing we looked at just a moment ago. And so you print these, you pass them out to the students, and there's a relationship between what they have on their desk with their pencil, what they see on the screen, and what you just modeled for them in a brief discussion. Now you get a true sense who really does understand what's happened today. We find that in a class of 24 students, some 4 to 6 are going to get right into this exit ticket and quickly get it done. Another 10, 15 are going to take a little more time, and then they'll kind of come around. And there's going to be there's going to be 3 or 4 who have really difficult time even getting started. And that's how you're going to see who's there and who's not. So this is formative assessment, and it's true formative assessment. So that's how the closer works in Conceptua Math. Rich tasks are another important part of Conceptua Math. Let's take a look at the rich task associated with a grade 4 unit in place value. It's called Sonia's Savings Plan. There's a unit launcher, which is a discussion for the class before they start the unit, and it orients the students to one of the uses for understanding place value, and that is the relationship between place value and money. So this is going to be a discussion about how money is associated with place value, and saving money is something that's important. And it's going to discuss what you might be saving for. What are your savings? And in this unit, we're going to be saving for gifts, and we're going to be saving for college and other things. Then, at the end of each topic, there is the actual real-world investigation. Each part of the real-world investigation includes a discussion guide and a lesson plan. Let's take a look at the lesson plan and see what this activity is like. Every real-world investigation has 3 parts, and the first part has data that's provided to the student by the authors. In this case, we see a chart, and the chart shows that Sonia is saving to buy gifts for her brother, her aunt, her relatives. And we see the list of gifts, the rounded cost, and the student's job is to calculate how much it's going to cost each week for 10 weeks to save to buy these gifts. And then there's some questions to answer about whether if Sonia saves $10 each week for 10 weeks, can she buy all the gifts? If she can't afford all of them, what can she afford? This is the second part of our 3-part real-world investigation. In this second part, students are dealing with much larger numbers. They're looking at tens of thousands of dollars, and they're looking at a very important social issue, which is saving for going to college. Here we provide some of the data, but students are asked to include some data of their own, to do research on a college that they would save for. So whereas Brian and Reed, who are Sonia's friends, are saving for Arizona State and Baltimore City College respectively, students are going to research their own. They're going to see what it will be to round to the nearest thousand and how much they'd have to save each year for 10 years. And this is pertinent. Many of our real-world investigations are about socially important areas of a person's life where mathematics plays a role in making good decisions. In the third part of the real-world investigation, it's always the case that students provide their own data. Here they're going to fill in this chart. They're going to determine what do they want to save for, how much would it cost, and are they rounding to the nearest dollar, $10, $100, or 1,000? Are they saving for 10 days, weeks, months, or years, and how much will that be? And so each one of these parts is designed to be one half-hour, 40-minute work session where there's an opening dialogue that's sponsored by the teacher and facilitated by our discussion guide technology. And there's even going to be a closing dialogue as well, where students have an opportunity to share the answers that they came up with. Let's share the work you did today. Let's have a few volunteers choose a row from your table and explain how you rounded the cost and determined the amount needed for 10 years. And so there's a really wonderful support system for teachers to do these kinds of real-world, rich tasks designed to be group tasks. So let's take a look at some of the details about Conceptua Math and look at differentiation in data as well. In grade 3 through 5, we have 280 lessons, these three-part lessons with the opener, the practice, and the closer. We have 21 three-part real-world investigations, so there's 63 rich tasks. K2 is coming out in January. It'll have both teacher-facilitated lessons and computer lessons, so students are working on computers about half the time and working with paper and pencil, manipulatives, and their own bodies another half of the time. And then we move into the area of assigning. How do you assign with Conceptua Math? You're going to use the class dashboard. You're going to choose an Assignments tab, and you're going to add an assignment. You're going to see either a view by domain or by grade, but in this case, we're looking at one particular customer, the Cobb County Public Schools. In Cobb County, they see their own framework, and you can do that as well with your school district. And you'd simply go to your own pacing guide, and you choose the conceptual lesson that's pertinent to you, and then you assign a topic. And then when students log in, this is the kind of screen that they see. They see their own progress. They can click on their assignment. They can use the tools that we looked at earlier. They can go to any lesson they want if you allow them to do so. And then they go to what we call fact fluency. And here they see their own data on fact fluency, and they start to practice facts. If they get something wrong, they get a model to support them, and then they have time fluency building exercises. There are differentiation capabilities built into every lesson. If a student is not sure what they should be doing, they can play a recently played video. It might have been a few screens ago. They play the last video to help them to orient themselves. If they think, gee, I'm too advanced for this. I don't need to go through all the questions here. Let me just skip to the skills check. They can do so with the teacher's login. And if, on the other hand, they really aren't ready for this lesson, they need to work more on a pre-skill or practice with more support, they can do that now while they're starting a lesson instead of waiting to get through an entire lesson. Teacher sees dynamic data where the colors correspond to the same colors you saw in the adaptive teaching screen. So if the students simply move right through, they'd have a green square, and if they needed a pre-skill, they'd have a purple square. You can click on the squares to see detailed data, and you can click on the student name to make an individual assignment just for them. You can look at fact fluency data for the entire class and see where your students are at with their multiplication and division facts. You can look at a downloaded progress report where you see every single lesson that you've assigned and how every student matriculated through that lesson. And then you can even look at another report we call the detail report. Here's an example of that detail report where for one given student we see every single day they logged in, how long they logged in for, and exactly what their progress was on every given lesson. In the program we have something called PD on Demand, Professional Development on Demand, which includes many different videos and descriptions to help you use Conceptua Math effectively.